Hi guys, welcome back. And today I will explain the reversible reactions and the equilibrium. What is the reversible reaction? This is this reaction that can go in both sides. So the products can react to form the reactant again. So reversible reactions are defined as the reactions where the product molecule can themselves react with each other or decompose to form the reactant molecule again. So there is a opposite direction of the reaction. The reaction takes two opposite directions. So the reactions can occur in both directions. The forward reaction is the direction in which the product is formed, while the reverse reaction, the reverse direction, is the reaction or the direction in which the reactant are formed back. Equilibrium is a state of the chemical reaction where reversible reaction reach a state of equilibrium, where the rate of the forward reaction that produce the product will equal the rate of the reverse reaction react in which the products decompose or react to form the reactant back. So both directions are proceed in similar or equal rates in equal speed. So in that case, which is the equilibrium state, the concentrations of the reactant and the product remain constant, although the individual reaction continue. Why? Because once the reactant are converted into the product, when they reach to the equilibrium state, the product will turn back in the same rate, in an equal rate to the reactant. So they have equal rates, and at the end, the reactant, both concentration will be equal. The Chalterer principle. It states that when a system at equilibrium is disturbed by changing the temperature, by changing the pressure or concentration, by adding any external factor that can affect the rate of the reaction, what will happen? The system will respond to that disturbance by shifting the equilibrium to counteract the disturbance, to fight the disturbance. For example, there is an equilibrium in a certain reaction, and we increase the concentration of reactant. Okay, so now the concentration of the reaction is high, of reactant is high, and um, so in that case, the reactant will go faster or more towards the direction where there is less moles of the substance, which toward the product. So more reactant will be consumed. While if the concentration of the products are increased, the reactant will shift its direction to or the equilibrium toward the side with the fewer moles of substance, which is supposed to be the reactant. So when we disturb the system under equilibrium, either by increasing concentration, the products or the reactant, the reaction will shift the direction toward the substance with fewer moles, with less concentration of substance by changing the temperature. Is another disturbance of the equilibrium of the reaction. So The reaction will be shifted depending on whether the reaction is exothermic or endothermic. If this reaction is endothermic, so it requires more temperature to produce products. And when we increase the temperature, it will proceed, it will be shifted towards forming the products because this requires temperature. This will take this temperature out. While if the reaction is exothermic, so it releases temperature, it will shift to the direction in which the change in temperature is finding, is the opposite. If we change the pressure of the reaction, this in gas phase reaction, the equilibrium position or the equilibrium will be changed if the number of moles of gas changes. Example, ammonium chloride dissociation. Ammonium chloride dissociation is a reversible reaction. Ammonium chloride dissociates into ammonia and hydrochloric acid. Okay, and hydrochloric acid will react with ammonia to form the ammonium chloride in equal rates. So there is an equilibrium. The forward reaction occurs when the ammonium chloride is heated, while the reverse reaction occurs when the mixture cools down. Which means this reaction is endothermic. When you heat it up, the products will be formed. When you warm it up, the reactant will be formed. Hydrogen iodide dissociation. HI, hydrogen iodide, will dissociate into hydrogen and iodine. This reaction is reversible. And the equilibrium depends on both the temperature and the pressure. Of course, because they are gases. And as temperature increases, the pressure of the gas increases. The application in industry, the Haber process for ammonia production. This is a process to produce ammonia by reacting nitrogen gas with hydrogen gas to produce ammonia. And this reaction is reversible. Ammonia dissociate into nitrogen and hydrogen. And this is the way that is used for the production of ammonia for fertilizers. The contact process. This is for sulfuric acid production. Sulfur dioxide reacts with oxygen to produce sulfur trioxide. So the forward reaction produces sulfur trioxide, while the reverse reaction regenerates the sulfur dioxide. Okay, so this is what equilibrium means with examples. Again, equilibrium takes place in a certain point in reversible reactions. Reversible reactions are the reactions that take place in both directions, in a forward direction to produce products and in an opposite or reverse direction to produce the reactant back from the formed products. When they are equal, the rate of the production of the product is equal to the rate of the reformation of the reactant. This is called equilibrium. when something or a factor disturb that equilibrium, like the concentration of reactant or product, like the temperature, increasing or decreasing temperature, like the pressure, the reaction will proceed faster towards the direction where it counteracts this disturbance. Okay? For example, when we increase the pressure for the reactant, so that the reaction will go in the direction that reduce the pressure, and it will go in that direction faster than the opposite direction, and so on. If there is a more concentration of one of of them, of the reactant or the product, the reaction will proceed in the direction to lower uh, with where the lower concentration exists, where the lower number of moles exist. We have applications for these reactions in industry, okay, like the sulfuric acid production and the ammonia for fertilizer. That's all for today, guys. Hope this is easy for you. If you have any question, don't hesitate to write it in the comments down below, and see you in the next video. Bye bye.